All right, let's just dive right in. Today, we're going to talk about two incredibly powerful techniques that can take your code from sluggish to, well, lightning fast. And I'm not talking about small tweaks here. These are fundamental shifts in thinking, real game changers for solving those super tricky performance problems you run into. So, you've been there, right? You've coded up a solution, it feels solid, it works on the small tests, but then you throw a huge data set at it and timeout. Ugh, it's so frustrating, especially in a coding interview where every second counts. You know your logic is sound, but it's just too slow. And here's the thing, the secret, really. Just throwing more code at it, adding another loop, making the logic more complicated, that almost never works. The real breakthrough, it usually comes from taking a step back and changing your entire approach. It's about picking a smarter tool, a data structure that's just perfect for the problem at hand. So today, we're going to unlock two of these programmers' secret weapons. First up, we'll get into hashing. Think of it as a shortcut for instant lookups. Then, we'll check out prefix sums, which are amazing for super fast calculations. And the best part, we're going to see how they combine to solve a really tough problem in a super elegant way. All right, let's get into it. Okay, first up, hashing. You can seriously think of this as the ultimate shortcut for finding stuff. Instead of having to sift through a long list one by one, hashing lets you jump directly to the exact piece of data you're looking for. It's amazing. Just look at this comparison for a second. On the one hand, you have the brute force way. Think two nested loops just to count how many times each number appears. It's simple, yeah, but it gets slow, really slow. We're talking O(n) squared time, which means as your list gets bigger, the time it takes just explodes. But then, look at the smart approach, a hash map, one single pass through the data. That's O(n) time. This isn't just a little better, it's a completely different league. It's a massive, game-changing improvement. So, what is hashing really? Well, it's a technique that takes some piece of data, any size, and crunches it down into a fixed-sized value. We call that a hash. And that hash basically acts like a direct address or an index in a big table. That's the secret sauce. It's what allows us to look up, insert, or delete things in what's called constant time, or O of 1. In plain English, that means it takes the same amount of time whether you have 10 items or 10 million. It's like having a magical filing cabinet where you instantly know exactly which drawer to pull open. Okay, let's walk through this. It's actually super simple. First, you just create an empty hash map. Then, you loop through your array, just once. For every element you see, you use it as a key. You ask the map, hey, have I seen this number before? If the answer is no, you add it to the map with a count of 1. If the answer is yes, you just bump its count up by 1. And that's it. By the time you're done with that single loop, your map has a perfect count of every single unique element. It's so clean, so elegant, and crazy fast. Now, of course, no tool is a silver bullet, right? Hashing has its trade-offs. For one, it completely scrambles the order of your data, so don't expect it to remember that. It also takes up extra memory to store that hash table. And it's definitely not the right tool if you need to do things like, find all the numbers between 50 and 100. It's a specialist, and its specialty is super fast, exact lookups. Hey, remember how I just said hashing is terrible for range-based questions? Well, that brings us perfectly to our second secret weapon. Let me introduce you to prefix sums. This is the absolute king of shortcuts when you need to calculate sums over any range of elements. The idea behind this is it's brilliantly simple. You make a new array, and in this new array, each spot just holds the running total, the cumulative sum from the original array up to that point. So the first number is the same, the second is the sum of the first two originals, the third is the sum of the first three, and you just keep going. Now, why do all this work up front? Because the payoff is huge. Once you have this prefix sum array, you can find the sum of any slice of the original array with just one single subtraction. It's incredible. So it's this two-step dance, right? Step 1 is a little bit of prep work. You spend a little time up front, just one pass, O(n) time, to build that prefix sum array. But once that's done, you're set. After that one-time cost, any question you have about the sum of a range is just a simple subtraction. And that calculation, it's constant time, O(1). That means it's instant. It doesn't matter if you're asking for the sum of 2 elements or 2 million. You never have to loop through that range again. Okay, and now for the main event. This is where it gets really cool. We've seen hashing, great for lookups. We've seen prefix sums, amazing for sums. They're powerful on their own, for sure, but when you put them together, well, they can solve problems that at first seem way harder. So here's the challenge. Imagine you have an array with both positive and negative numbers, all mixed up. Your job is to find out how many different continuous chunks of that array add up to exactly 0. If you try to brute force this, you're looking at a nightmare of nested loops. It's going to be slow. But we can be so much smarter than that. And this, right here, this is the key insight. It all comes from our prefix sum idea. So picture this. As you're calculating the running total, let's say at index I, your sum is 10. You keep going, and a little later, at index j, the running sum is 10 again. What does that mean? It means everything in between I and j must have perfectly canceled out. Their sum has to be 0.
Okay, so that's the key insight. But here's the next puzzle. As we're calculating our prefix sums one by one, we need a really, really fast way to check, hey, have I seen this particular sum before? And if I have, how many times? We can't just scan through all our previous sums every time. That'd be way too slow. We need some kind of instant lookup.
And sound familiar? That's right. It's our first tool, the HashMap. This is the aha moment. It's the absolute perfect tool for this job. We can use a hash map to keep track of every prefix sum we've seen so we can check for duplicates instantly. This is where our two secret weapons combine into something beautiful.
So here's how the full algorithm works. You loop through the array one time, keeping a running sum. At every single step, you look at your hash map and ask, have I seen this running sum before? If the answer is yes, then bingo, you've just found one or more subarrays that sum to 0. So you add the frequency of that sum from the map to your total count. And then, before you move on, you update the map with the sum you just calculated. You either add it for the first time or just increase its count. The result? A brilliant solution that runs in a single pass, ON time.
And listen, this is really just scratching the surface. These concepts get even more powerful. You can expand this to 2 dimensions and use 2D prefix sums to instantly find the sum of any rectangle inside a grid. Or you can use a clever twist called difference arrays to update entire ranges of an array all at once in constant time. The core ideas are exactly the same, they just scale up.